Hello everyone in CSC-134 C Programming. As you know, our face-to-face class has been moved online until further notice. I suppose some decision will be made sometime this week if we're continuing on online subsequent to this week. That would be the week of April 1st. Look for more information as the week and the situation evolves. So we're starting week 9 after an extended spring break, as everyone knows. And Module 5 is on functions. Now that's actually Chapter 6 in your textbook. So for the next 2 weeks, we will be working in Chapter 6. I posted a little video message out there. It's not very long. It's 2.5 minutes long. If you haven't already looked at that, you can play that short video. It speaks to the use of this Calendly link to create an appointment with me where we can talk on the phone, use Zoom meeting, or use Teams, or just work things out however. So, but all of our meetings will be virtual. The building where our class is held is actually closed, so we couldn't get in there to meet. My office is in that same building. We couldn't even get in there if we wanted to. So let's talk about functions. But before we do, these are the items that were due at the end of Module 4. And you can see that was the homework questions on Chapter 5, Project 6, Project 7, the Code Lab, and the Module 4 exam. If you've had now 4 weeks to get those done, so hopefully that's more than enough time. They were actually due prior to spring break, but I had told everyone that they could turn it in at the end of spring break if they wanted to, and I wouldn't count any points off for being late. So that's the list of work that was due 2 weeks ago before spring break started. So, speaking to functions, they are our primary building block for modular programming. Modular programming is taking a problem and breaking it down into smaller steps, smaller, more manageable steps. And you can see some of the advantages to modular programmings are our programs are they're easier to understand, maintain, and troubleshoot because the tasks are divided into smaller problems. So we've been using functions since we got started in this class, really. As you know, every C++ program has a main function. So let's pop over here for a second, and I'll open up something in Genie, and here's just a little template program like I use in the classroom when we were meeting face to face. It just has some comments at the top. It has the include for IOStream. It has a using namespace standard. And here's our one function that every C++ program has. So you should be able to tell that this main function is of the type integer. And as you can see here, it returns 0. So that's just pretty much an empty shell of a C++ program. Now, functions have a couple different parts, and you can see those parts right here in this image. Okay, so this line, let me see if I can get my windows arranged here a little bit better where we can see both things at once. Okay, this line right here is the function signature. I think your textbook actually refers to it a different way. I'm trying to see here in the book how they actually refer to it, but that is the function signature, and the line that in the definition that reads int main is also called in your book, this line right here, the function header. So this line that says int main with the 2 parentheses, your book says this is the function header. You may also hear it referred to in other languages and in other places, even for C++, as the function signature. So parts of the function main here, it has the function name right here. It has the return type for the function. And by the way, a function is really a variable that points to some code in memory. Okay. Now, you notice right here these 2 empty parentheses. It says here in my little graphic the parameter list, and this, of course, our main function is taking nothing in. Okay. This part right here inside the 2 braces is called the function body. So those are all the parts of the function. So we could make this this particular program call another function, and I think we have actually done this in the past. But let's say we wanted to create a function to square a number. We could do something like this. I always put my braces in there so I don't forget. Okay, and we could then just say return num times num. Okay, and then we could actually do something like this. Let's just say num2 square equals 2, and then we could see out, we could call that function square. You see, Genie's smart enough to tell us what the function header is, or what the function signature is. Right here it's saying that the square function returns an int, and it has a parameter that it takes in that's called num up here. Doesn't matter what we want to call it down here. Okay, and there's our semicolon. So we could try this out now, and I'll go ahead and make this bigger. Okay, so let's build it and run it and see what happens. So down here is where we're calling that square function. And the way C++ and most other languages work, you put these parentheses on the end of the name of the function, and that causes it to actually run the function. So let me put my semicolon in up here so that it'll compile, and let's try compiling this now. Let me save it as a different name here. Test square function. How's that? Okay, so let's go ahead and build it. And let's see, num to square. Okay, say an unused variable. Let's see what's going on. Oh, I left my semicolon out. Okay, let's build that again. You can see that it built successfully, and so we could try to run this. So let's go ahead and run it and see what happens. So, okay, I'm running it off of my flash drive, and I'm on Linux, so you can't do that. So we'll have to save this a different place. I'll put it in my downloads folder, and we'll create a functions lecture. Okay, so we'll save that and we'll build it again here. Okay, so you saw some of the security that's built into Linux. You can't run something without giving it run permission. Genie's smart enough to do that as long as it's on a drive that you can give something run permission. Since Windows doesn't know anything about execute or run permission, couldn't do that, couldn't run this off of my flash drive. So we'll run it again here, and you can see there's the 4 coming back from where we ran our function to square that number. This, inside the parentheses here, this is called a parameter. Down here, where we're actually running the function, it's called an argument. So those items are talked about in your textbook. So down here, this is an argument. Up here, it's a parameter. Now, what happened when we ran this? This num to square went into the square function, and the square function got a copy of it. So it made a copy of this, whatever the contents of this variable called num to square is. It made a copy of it, it worked on it, and it sent it back to us with this return statement. So this right here, this function call, when C++ evaluated it, the name square took on the value of num times num. So there's something called function prototypes, and let me show you why we would use a function prototype. Right now, you could see this program built and ran successfully, and it did so because when the compiler compiles the program, it looks through this thing from top to bottom. And as long as it knows what square is, it's fine with us calling it right here. But if it hasn't seen square, if it hasn't seen this function square, and it doesn't know anything about it, then our program will not compile. So let me take this and cut it, and I'll put it down here. Okay? So as you can see now, main is above square. So let's try to compile it now and see what happens. What does it say when I tried to compile it? Square was not declared in this scope. So it has issues with us right here. See the red wavy line? It has issues with us trying to call square because it doesn't know what square is. Even though we have created it down here, it still doesn't know what it is up here. So that's where we can use a function prototype. And most folks do this simply because if you're thinking about how this program runs, and usually the way structured programs work is you have a main function, and the main function calls all the other functions. So if you were reading this, you might, start at the top, start reading, and you'd see, oh, here's the main function. Okay, I know this thing's going to call everything else. And then you'd scroll on down and try to find where square is to see what happens in square. Well, function prototypes let us get around this limitation of having to, the C++ compiler having to know about that function before we actually define it down here. So let's create a function prototype here. Okay, I'm going to create a function prototype for square. Int square. Okay, there's my function prototype. Now what did we just do? We basically dummied up a square function. We told it that it's going to take an int in, and we told it what type the square function returns. But you notice that this function prototype does not have, remember we called this the body of a function? It doesn't have a body at all. But this right here is a function prototype, and it's enough so that C++ will go ahead and let us call this function, and it's okay with it. It doesn't have to know what happens inside it yet. Okay, so let's build that. You see it built fine even with the square down below where it was getting called, because we did a function prototype. Okay, so that was a lot of concepts in a small amount of time. So I'm going to back up and kind of talk about some things that are in the book. We did a lot of stuff in this one program. So first, let's look at this program. This is a program out of your book, and it's got a main function here. And you'll notice that the main function says I'm starting in main, and then what's it do? It calls the first function that's up here. Okay. It calls the second function that's up here, and then it says I'm back in the main function again. Okay, not really a whole lot going on with this. Some things that I want to point out to you though. Notice that the type on these two functions is what? Void. Void means they don't return anything. Void means nothing is there, so nothing is returned. And you can see this function doesn't have a line in it that says return 0, does it? Our main does. These two functions don't. That means they're actually void. Something further, in some languages you have to do this, like I think Java has a rule that this has to happen. Even though we don't have anything inside those parentheses, some languages will force you to do this. So what's that saying? Well, it's saying that first off, this second function doesn't return anything. It's also saying this second function doesn't take anything in. And we could actually have that here as well. And if I build it, you see C++ is fine with that. we just went ahead and were more explicit about what's going on with this program. So let me save this to the folder that I put out there in my downloads. That's on my hard drive, so that I can run these things. And let's see. Thought I had created a folder out there. Maybe I created it on my documents. That's where I did. Okay, let me save it in here. And then we'll build it, and then we can run it. And you can see there's what happened when we ran that program. So it starts off here, starts off right here. I'm starting in the main function. It then goes up here. It calls the first function, so it goes up here. It says I'm now in the first function, and then the second, and then it's back in main again. Okay? Nothing special there. Remember, we could put prototypes in this program. This is what it would look like if we used function prototypes. We cut that stuff, we put our functions down below here, and then we could add some prototypes. Okay, and really you can almost, just do this with what we've got going on right now anyway. Void first, void second. Remember to put that semicolon on the end of the prototype. Okay, so now I have moved the main up to the top of the program. Okay, and then I've got all the functions that are being called by main down below. Okay, so we can build this again. You can see that it still builds just fine since I put my function prototypes in there, and we're good to go. Okay, so function prototypes. So next, let's talk about how to, well, there are a couple concepts, okay? Following our checklist here, we've gotten through this, right? Everybody knows what the return type is, the name, the parameter list, and the body. We know that. Here's where it's talking about void. Okay, here's where it's talking about calling a function. We did that. Here's where it's talking about function prototypes. We've done all this. Okay, we have done a little bit of this already on number 4, where it's talking about defining formal parameters. And so what about some of these concepts of scope, lifetime, and initialization? Okay, now I want you to notice that there's a difference here between local variables and global variables. Okay, so let's talk about a local variable versus a global variable. I want to point something out to you. We've already run into this in class before, but do you remember when we were writing programs and we would get some strange answers if we were totaling things up unless we initialized our total to 0? Here's where we're actually being told that on our checklist, and this is in your book as well, but initialization of a local variable, it's not initialized to 0 or null. It could have anything in it, and we've seen that. If you have a global variable, C++ does initialize it to 0, or if it's a string, it's going to be initialized to null. Okay, so let's figure out what's local and what's global. So we'll pop back over here, and let's see, I had a square function right here. Okay, this is my square. All right, so inside here, if it's inside of a function, if it's declared inside of a function, this is a local variable. Okay, and by the way, down here where we have int num, we said that's a formal parameter. It actually creates a local variable inside of that function square. So int, even though it's inside the parentheses here, int num is actually a local variable inside of square. Okay, now for something to be a global variable, it would have to be declared outside of any functions. So right here, I could say int global. It doesn't have to be called global. How about we do this? Int g underscore num. Okay. This is a global variable. And we know from what we were just reading on the checklist that a global variable is initialized to 0. So we can get to this variable because it's outside of any of these functions here. We can get to this global variable from any function in the program, and we can change it from any function in the program. Sounds pretty cool, huh? Well, it is, but it isn't. If you just used global variables for everything, you would be getting yourself into a whole lot of trouble, because the whole idea behind a local variable is the old Vegas rule. What happens in Vegas stays in Vegas. If we do something to this num to square inside of main, it doesn't get out and affect square or all the other functions in our program. So global variables are discouraged strongly in structured programming. And if you write a program with global variables, for a programming test or something for employment, odds are you're probably not going to get the job, just because they'll say, oh, we don't want that. But let's go ahead and see that we can change this from any of these functions. So I've got this global variable that I call g underscore num. Now right here, before we return from our square function, I could do something like this. G num equals g underscore num plus 1. Oops. Plus 1. Okay. So I'm going to add 1 to it, and then up here I could print it. See out. I'm just putting some text here so that we can see what's happening. Okay, let's put an indel on that too, just so we go to a new line. Alright, so what's happening now? We're creating a global variable up here outside of any of our other functions. So it's global. Okay, that means we can get to it anywhere. We can change it from anywhere. So when our main function starts, we're calling our square function. and sending it to out. Okay, and we'll go ahead and add some descriptive text here. Result of squaring 2 is, whoops, wrong direction. Okay, so when we run this, we'll see that we get the 4, and then it's going to tell us what gnum contains. But because we called the square function here, what's happening to gnum? We're bumping it by 1. So we said this was initialized to 0 by C++ according to what's on our checklist and in our textbook. So if this had a 0 in it, we added 1 to it, we should get global gnum contains 1 from inside of our main. So let's build it. Okay, it says it built successfully. Okay, so let's run it. Okay, now I didn't put an indel on the end, so there's a result of squaring 2 is 4. And then what does it say is in global gnum? A 1. So you could see we were able to change it here inside a square. We were able to get to it here. So indel, how's that? Build it, run it. That looks better, doesn't it? Okay, so global variables, really discouraged in the real world. But if you wanted to use a global constant, everybody's fine with that. If you wanted to do something like this, okay, and have a global constant for maybe a global tax rate or something, equals, I don't know, 0.78, let's say NC sales tax, 0.7. We need to make it a double. Okay, so now we've got a global constant that anywhere in our program that we wanted to use the tax rate, we could use that. We can't change it, so you don't have to worry about it getting changed inadvertently by somebody messing up some code. Okay, so we could get to this anywhere in our program, but this line would blow because we're trying to change it, but we could get to it here. And usually constants are capitalized, so we'd have something like G tax rate. Okay, because it's all caps like that, folks know that it's probably a constant. So let me do something like this. Okay, we wouldn't be able to do anything with it down here, so we could just print it though. See out. Okay, and you'll see we could get to it from any function that we wanted here. Same thing, right? Get my tabs working right. Everything's lined up now. So nothing spectacular there. We're getting to the global tax rate there, and we're getting to it there. So let's see, num to square, indel. Okay. So trying to figure out why it's wrapping over like that. That's getting called global tax rate. That's happening before the call. Maybe we need to do a flush or something. I'm getting a global tax rate up there at the top before I don't know why that's coming out right there, but see out from inside of the square function. Oh, I see it right here. It's doing this, and it's calling square, but we're actually printing this inside of there. So that happens before we actually get the number from square right here. So you can get into some strange situations there when you're calling things. So okay, so we talked about a couple different things here. We talked about the initialization. We talked about what makes a variable global. We talked about what makes one local. But here's the thing. This variable, anything that we have inside of a function, is only alive as long as that function is alive. When that function goes out of scope, like after it's called right here, whatever's inside this function is destroyed. So there's an example that goes over this in your book about making a variable static. But before we do that, let me go ahead and show you about shadowing a variable. So here we've got this global tax rate of 0.7. Okay, if we are inside main here, and we let me go ahead and clear that code out. If we're inside of main and we create another G tax rate, okay, it's going to shadow over the top of our constant. So we won't be able to get to this G tax rate that's outside at all. It shadows it. So right here I'm printing G tax rate, right? And we had it set to 7. If I come in here and I do something like this, double G tax rate equals 0.9, okay? This local variable shadows the global. Okay, so this one is going to shadow over the top of this one. We're never going to be able to get to this one. We just shadowed it. So it may give us a warning when we try to compile it, but I think it'll go ahead and compile. Now it didn't even give us a warning. So let's run this and you'll see that we're not able to get to the, what's it say the global tax rate is? 9. That's because we shadowed over the top. We shadowed or stomped this one with the copy that's in here. So that's the concept of shadowing a variable. Okay. Well, let's talk about lifetime of variables, and there's a good example in your book that we can use for this. I think it's one that has a static in it. Let's see, it's not 620, I think it's 623. Let's see. Yeah. Okay, so here's our function prototype for show static. Okay. Now this one creates a variable called statNum. It sets it to 5, okay, and it prints it, and then it bumps it by 1. Now I'm going to run this, and I want you to think about it for a second. This for loop is going to call this from 0 to 4, so it's going to call it 5 times, and it's going to show what's in that variable, okay, over and over and over. So each time through it's going to bump it by 1, so we should get something like 5, 6, 7, 8, 9, 10 maybe. So let me go ahead and save this to my functions lecture folder where I can actually build it and run it. Okay, here it built, fine. Let's run it. What's it say? Statnum is 5, 6, 7, 8, 9. Okay, now I want you to think about this for a second. We're bumping static num 5 by 1 each time, but this is something new that we haven't talked about. If you put static in front of this variable here becomes immortal as far as our program is concerned. Rather than being destroyed after each time this function is called, this variable hangs around. So you saw when I ran this right now, I get 5, 6, 7, 8, 9. Okay, let's take this word static off and watch what we get each time. What do I get now? 5, 5, 5, 5, 5. So even though we're bumping it by 1, at the end of this function show static, that variable is destroyed. It dies and it goes away. And a new copy is created the next time we call it in this for loop. So static works pretty nice if you want a variable inside of a function to stick around as long as the program is running. Okay, so that's a real important concept when we start talking about, maybe you wanted to have a total in here or a count or something, and if you didn't have this, the only option we would have would be to make statnum a global variable so that it would be alive as long as our program's alive. But if we made statnum a global variable, then somebody could change it from another function, and we don't want that. The only place we want statnum to be able to be changed is inside of this function right here, because it makes our programs more reliable. Okay, so let me show you one further thing with this. If I have declared statnum inside of show static, do you think I'm going to be able to get to it out here in my main program? Let me send it. Let's say something like this. Statnum contains. Let me put my symbols here. Okay. And L. Okay. So I'm trying to get to the variable called statnum that is defined down here in show static. Now those of you guys that have taken Python, we have a whole chapter just on the scope of variables, and you know that I'm not going to be able to get to statnum from inside main. But let's go ahead and try to build this, and you'll see that I don't think it'll build. What's it say? saying something about stat num doesn't exist, right? Was not declared in this scope. Okay? So we can't get to stat num from outside of stat num because it is a local variable. It's declared inside of this function. So a local variable. So there's no way really for us to change it inside of here. There's no way for us to change this stat num from inside of main. Okay, just can't do it. All right. So there's no way if we talked about with this square function here, there's no way if I wanted to do something like this, in our square function, there's no way for me to get back a result. Or maybe I wanted to do this. I wanted to say something like this. I'm trying to take whatever's in num, multiply it by num, save the result back into num. Okay? This, because we have our function signature int square, this is actually saying pass whatever comes in, create a copy of it, also known as passing by value. That means that even though we've got num square out here, num square is never going to get changed right here. Okay, let's try this. See out. Okay. So here I'm calling that function. The function is doing this. Let me go ahead and return num. Okay. The function is actually changing this num, right? And we sent num to square into the function, but watch what happens when I print num to square. Do you think it's actually going to change it after this function is run? It should, right? I mean, we're saying num equals num times num. So it should get 4 in it because we're returning that right here, and we'll see that this returns 4. We've already seen that. But do you think it's going to touch the num to square that's out here in main? Well, let's compile it and run it. What's num to square got in it? 2. Even though we did this. So, how could we ever, if we wanted to change what was sent to that function right here, how could we ever do that? Well, that's talked about in your textbook. There's a section about passing a value by reference. Let me go ahead and clean this up a little bit. So, passing by reference means that instead of C++ making a copy of the variable or the whatever was passed in here, instead of making its own little copy of it and messing with only the copy here, we could mess with the real thing. We could mess with this variable right here from inside the function down here. So the way we do that is we pass it by reference. And you do that by doing something like this. This says pass by reference. Okay? And most of the time they'll do it like that, but it can have a space in there. Now, remember that if we do that here, our function prototype has to have that in it. So you saw that when I ran this before, it didn't change it, did it? Let's go ahead and add some descriptive text here. Num to square contains. Okay, so because I'm passing it by reference now, if we change it, it's gonna be reflected in this. So when we print this now, we should see a 4 in num to square. So let's build it and run it. What does it say num to square contains? 4. What does it say that the result of squaring it is? 4. So we actually changed this down here because we passed, our parameter got passed by reference. So what does by reference actually do? It's passing the memory address of where num to square is located in memory down to this function. So we're operating on the live data. We're operating on the real thing down here rather than making a copy of it. Hopefully you can see that you probably don't want to do this very often. There are situations where we need to, change this up here, but most of the time it's a lot safer. It's a lot safer to not pass by reference. So if we mess something up here, we don't mess up our original. Okay? So just keep that in mind, that you can pass by value. If we pass by value, the function that's getting the parameter gets a copy of it, makes its own little copy. If we pass by reference with this ampersand, then we're operating, we get the memory address of whatever was passed in here. We're getting a memory address of it, and we can change it down here. Very powerful stuff. Can't really do that in Python. There are some ways around it, but you can't really do this in Python with just a regular variable. Okay? You can't pass by reference in Python. In C++, we have this ampersand thing. We changed our function prototype here. We changed our function signature here, or header, and that means we can mess with the real thing. Okay? So that's the function chapter in your book. We'll talk a little bit more about it next week, but the exam will also become available next week. The exam is just one part, but you have a program that's a little bit more complex than some of the other programs, and I will create a video to kind of introduce that program to you so that you can get started with that program this week. And then you can also we could talk about some code lab items if folks will email or send me some requests for code lab items. So good luck with the material this week. You remember that you can set up a phone call with me. We can move it to Zoom or Microsoft Teams if you need some help. And I can also, if you just have a list of code lab items that you want me to try to explain, we can do that in a video and post it out there so everybody will have it. So we we covered every single item on the checklist here: scope, lifetime, initialization of variables, both local and global. We actually talked about static variables that aren't on the checklist this week. And so, good luck, stay healthy and safe, and we'll be around